Hello everyone and welcome back again to the linear algebra component of the Calculus and Linear Algebra series. In the last video we outlined how we might go about constructing number systems as solutions to certain types of equations. So for example, if we took the perspective that we only kind of considered the natural numbers to be the ones that we could work over, and we took an equation like of the form x plus 2 equals 1, that thing we would say has no solutions in the natural numbers. But we defined minus 1 as the solution to that equation. And in a similar way, we can construct all the negative integers and define them to be solutions to certain types of equations, like x plus 3 equals 1 would define x equals minus 2, x plus 4 equals 1 would define x equals minus 3, and so on. Right? You can keep going on defining all the negative integers. And similarly, we discussed how we could go about constructing things like the rationals and the reals in this manner. And the point is here that we introduce these things as kind of an abstract idea. We just define them as solutions to equations, and later on we realized that we could interpret these things in a geometric way that was particularly useful. In fact, we saw there were two different geometric ways in which we could interpret these numbers that we defined to be solutions to the equations. And that was, we can think of them as how they act on the real number line in an additive way. That was, we thought of them as things that shift the number line left and right in this transformational way. Or we could also think of them as how they act on the real number line in a multiplicative way. That was in how they stretch or squish the number line, fixing 0 at its point. So there was, on the one hand, this visual perspective that we took of the numbers, but initially we just simply defined them as these abstract things that were solutions to these equations. And I want you to keep in mind this particular idea for this video, and we will come back to this visual idea in later videos that will be particularly useful when we want to kind of visualize what the complex numbers are. But this algebraic way in defining numbers as solutions to equations is going to be particularly useful for this video, where we're going to define what is known as the imaginary unit. So that being said, let's go to something now that you are hopefully all rather familiar with, which is the quadratic equation. So we're going to consider an equation of the form ax squared plus bx plus c, and we're going to take a, b, and c in the reals here, but we're going to remove 0 for simplicity. So it's well known, and hopefully you've done this in school, that the solutions to these equations are given by the quadratic equation. You might have a nice little song to remember this thing, but what we notice here is the kind of two important features. One is we have the plus and minus, so that tells us that there's generally two solutions, or in most cases there's two solutions to these types of equations. And we also have this square root of b squared minus 4ac. And we know that the square root is quite restrictive over the real numbers because we can't define the square root, or we don't seem to have a square root of real numbers that are negative. So that's why we have a special name for this thing inside the square root, because it allows us to split up this solution space for this equation. And we call this thing inside the square root the discriminant. And as you might expect, when b squared minus 4ac is greater than or equal to 0, we say that this equation emits real solutions. And that's because when this thing is greater than or equal to 0, we can indeed take the square root of positive real numbers, including 0 as well. So we ask ourselves the question, what happens if this thing is negative? Are there no solutions? What can we do? In general, when you did this in school, you would say, oh, there are no solutions to this equation, therefore I can't write any down, right? I can't conclude anything. But this is no different in the mindset, where we think about that equation x plus 2 equals 1, where we had our perspective that we could only work with the natural numbers. That also has no solutions in this perspective where we only work over the natural numbers. But we defined minus 1 and in turn all the negative integers as solutions to these types of equations. And this is particularly useful because it turned out later on that these negative integers were particularly useful for kind of other things in society. And we want to take this in mind that at the moment, because here we're now working over the real number line, all we're saying is that this thing does not admit solutions if we only contain our perspective to the real number line and when b squared minus 4ac is less than 0. So maybe we should extend our numbers again, right? Much like how we extended the naturals to the integers. Maybe we should extend our real number line to a new set of numbers that we haven't yet discovered. So kind of continuing that line of thought, let's look at a particular type of quadratic equation. And the quadratic equation that I want to take here is x squared plus 2x plus 2 equals 0. Now putting in the values of a, b, and c into the quadratic formula, it's fairly clear that the solutions that come out are going to be of the form minus 1 plus the square root of minus 1, or minus 1 minus the square root of minus 1. And we say, okay, there's not much hope here because x squared is strictly greater than or equal to 0 for all x in the reals. So there are no solutions, as we said before, because the square root of -1 we can't take, right? Well, there's no hope. But let's suppose that we just define the square root of -1 as some new number, much like how we defined -1 as the solution to the particular equation x plus 2 equals -1. So let's suppose now that we just define the square root of -1 to exist. We're not going to worry about what it means yet. We're just going to say, much like how we did it for the integers, we want to say the imaginary unit is defined to be the square root of -1. And as I kind of said before in the previous video, it's not yet the task to try and interpret what these things mean in the real world, whatever the real world means. Like, we don't need to tie some physical relevance to this thing yet. We're simply saying that we have an equation, we have some solutions to that equation, and those solutions don't appear to exist in our current perspective of the number line. So let's extend it by simply defining the square root of -1 to be this unit called the imaginary unit I. So we write the square root of -1 as I. And it is common for the imaginary unit, just as a notational point, to sometimes be denoted by J instead of I. And this is very common within physics textbooks or engineering textbooks, because sometimes I is used to denote current when doing things in electric circuits. And generally, actually, we'll see that I, or you will see in your other courses, that I generally appears a lot in electrical circuits or other areas and other physical disciplines. So let's just kind of reiterate what we've done here. That we started with this equation that was x squared plus 2x plus 2. It gave solutions of that had this term, the square root of -1 in. We say that the square root of -1 doesn't exist on our number line, or our real number line. So let's just define it to be this new number, which is called I, the imaginary unit. So we define I to be the square root of -1, much like exactly how we define the negative integers as simply solutions to equations of the form something like x plus 2 equals 1, right? We define -1 to be the solution to that, and in this way we define I to be, in this case, the solution to the equation x squared equals -1. That's how we're going to define it. And then what we'll do is, kind of starting with this definition, much like how we defined our numbers in the first video, later on we'll realize how we can interpret this thing in a very intuitive geometric way, both in a multiplicative way of how it acts on the number line and in an additive way in how it acts on the number line. So that's where we're going to finish off this video. And in the next video, what we're going to talk about is we're going to talk about how we can now extend our real numbers to what was known as the complex numbers using this imaginary unit I. So once again, I remind you to always look at the notes after the video. And again, I don't think there's many problems that you can do after watching this video in the module handbook, but to try any of the problems if you can. So thanks very much for watching, and see you in the next video.